So we've talked about testing. Now let's assume we've run a bunch of tests. We've built some really nice test suites based on both black box testing and glass box testing. And we've isolated that unfortunately our code has one or more bugs. It's not behaving as expected. We're now ready to turn to the task of debugging, removing those bugs from the code. A little quick aside, because there's often some fun stories about, so where does the term debugging come from? And it's often claimed that the first bug was found by a team at Harvard that was working on what was then called the Mark II Aiken relay calculator. So it was a giant computer a long time ago built out of vacuum tubes. And in that test, the team was actually running a set of tests on a particular module. We're getting funny results. And because it kept failing, the staff actually went in and inspected the actual machinery, in this case a bunch of big vacuum tubes and electronic relays, and what they discovered was this. In fact, they found a moth had flown in and gotten trapped between the connections of one of the tubes and was causing a short circuit. And this was, as you can see here, says, first actual case of bug being found. It's a wonderful story. It's a cute story. But it's probably, and the story, by the way, is true, that they did find that moth. It's part of the files that they kept. But in fact, the term is probably older than that. And indeed, if you go back into the late 1800s, you can find in a textbook, at the time, a popular textbook on electronics or electricity, says, as you can see here, the term bug is used to a limited extent to designate any fault or trouble in the connections or working of electrical apparatus. So the term is probably older. But the story about finding a literal bug in a piece of machinery is certainly delightful in thinking that that's the etymology of the term. However, what we really want to turn to now is to talk about how do we do debugging. We're going to do that in the next section, but before we do, let's say a little bit about the kinds of bugs that we might expect and why they have different impacts. When we expose a bug, a runtime bug, that is something that occurs during the running of the code, as opposed to a static semantics or a syntax error. One dimension along which the bugs can vary is the difference between an overt and a covert bug. Overt says there's an obvious manifestation. Code crashes. Code runs forever. It's clear that there's a bug. Covert is a little more subtle. There's no obvious manifestation here. The code returns a value, but that value may, in some cases, be correct, but hard to determine. And that's clearly more worrisome. When it's really clear, it's nice. When it's not so clear, not as good. Second dimension along which we could think about bugs are the difference between a persistent and an intermittent error. A persistent bug occurs every time the code's run. Every time the code runs, it crashes. Pretty obvious. Intermittent only occurs sometimes. That's a little more annoying. Sometimes it's because it only occurs on particular inputs, but in fact there can be intermittent errors that occur only sometimes, even when run on the same input. And that's also a little bit frustrating. The reason we're going to give you these different categories is that the fact that there are different kinds of bugs has an impact here. So, in sort of increasing order of worrisomeness, an overt and persistent bug, obvious to detect and really easy to correct. And indeed, good programmers will use what we call defensive programming to try and ensure that if an error is made, the bug will fall into this category. Defensive programming says if I've got an expectation of what conditions are in an input, I might test for them before I actually run the code and throw an error. That'll make it really obvious if I've got the wrong kind of input coming in here. So an overt and persistent bug, easy to catch and easy to detect and hopefully easy to fix. Overt and intermittent are more frustrating because they can be harder to debug. But if the conditions that prompt the bug can be reproduced, usually we can handle those. And those are bugs that are more annoying, but still things that we can deal with. The covert bugs are the ones that are really scary. Because a covert bug says, I'm not going to be obvious to detect this, and in particular, it may also be intermittent, even more worrisome, but a covert bug says, code returns a value. So it's not that it breaks in some way that it's going to be obvious. And if the code returns a value, but a value that's wrong, how long does it take before I find it? I might run code for days, weeks, months before realizing that the values I'm getting in are wrong. And if that's code inside of the control system for an airplane or inside a banking system, These can be really dangerous errors and things that are going to worry me a lot. Defensive programming, this idea up here, will help catch a lot of bugs ahead of time, but the subtle ones can be hard to deal with, and we're going to have to try and come up with ways to help find those tools. And in the next segment, we're going to begin talking about tools for actually doing debugging.